Good Friday or Monday to you. This slide deck is for the 16th or 19th of October, Mr. Cohen's class during synchronous learning. If you were unable to attend because of other pressing matters, this is for you. If I needed a sub, this is also for you. So we're going to learn how to distinguish between the hypothesis and the conclusion, identifying the subject of the conditional statement today. There was one YouTube video or and an assignment, and then two additional ones on counterexamples. So we're going to talk a little bit about counterexamples as well when the hypothesis is true and the conclusion is false. Question about you watching the videos. This would be more helpful to you if you watch them before watching me go through the details of identifying conditional statements. So when you identify the subject, hypothesis, and conclusion of a conditional statement, you're going to be able to rewrite it using if and then, and also identifying whether it's true or not. We're going to provide counterexamples when a conditional statement is false. So for conditional statements, it consists of two conditions that have a relationship to one another. It has an if-then structure, like if this happens, then that will occur. The conditional statement has two parts called a hypothesis, if, and a conclusion, then. The conditional statements are nothing more than if-then statements. We'll sometimes use letters. This isn't at the beginning or end of the alphabet, but P is the hypothesis, the if, and Q is the conclusion or the then. So if hypothesis, then conclusion. The statement can be given a conclusion or consequent. So this would be an important vocabulary word. Conclusion, you'll sometimes hear as consequent. If you're taking notes, you're on the first page. It's either 1016 or 1019. And so maybe write down the if P then Q. Q again is the conclusion. I would abbreviate it CON, CL. And the P is called the hypothesis or antecedent, P or HYP for hype. Remember, there's a P in hype for hypothesis. Don't worry about spelling. Just try to see that there's a hypothesis, if, and a conclusion Q, or conclusion Q, then. So here's the notation with the arrow leading from the hypothesis to the conclusion. And it's called a conditional statement. The subject or the noun of the conditional statement, or CONDIT, if you want to abbreviate like I like to, has some subject being affected by the if-then. So the subject is the main clause. Again, we talk about antecedents and consequence. I'll only mention them in passing. You may hear about them in more advanced classes. So if it rains, then the picnic will be canceled. If a number is even, then it is divisible by 2. So our success criteria is to identify the hypothesis and conclusion of a given conditional statement. So we're going to underline the subject, box the hypothesis, and then circle conclusion, circle the conclusion of the conditional statement. If I am a student, then I go to school. So let's see where our box and circle are. We box the am a student, that's the hypothesis. We circle the conclusion. If a polygon is the subject, is a triangle, then it has 3 sides. So let's try it. If a polygon, underlined, is triangle, there's your box, for the hypothesis, then it has three sides. Conclusion. Note, if you ever are flipping the hypothesis and conclusion, the subject will not move. So let's try some more practice. If you are an American citizen, then you have the right to vote. You being the subject, are an American citizen is the hypothesis, right to vote is the conclusion. If a figure, subject, is a rectangle, then it has four sides. Rectangle is boxed. That is our hypothesis and our conclusion. Then it has four sides. Conclusion, circle. If you want to be healthy, then you should eat vegetables, which would be our conclusion, even if you don't like them. So a conditional statement and hypothesis, a little bit more on that. Here's some funny things. All students like geometry, haha. If you are a student, then you like geometry. We've taken a statement that does not look like if-then with a subject, and we've changed it to an if-then statement. I bring my umbrella when it is raining. Take a minute to think about what you would do to change this into an if-then statement. If I bring my umbrella, I being the subject, then it is raining. Let's see if I got this right. Oh, I didn't. If it is raining, so we have to switch, then I bring my umbrella. Notice sometimes we still have to switch the if and then. So the raining has to happen before I bring my umbrella. I can rewrite a statement in the if-then form. A number is divisible by 4 if it is divisible by 8. So if it is divisible by 8, then it is divisible by 4. The subject is number. An acute angle is an angle that measures less than 90 degrees. If an angle measures less than 90 degrees, then it is acute. Hope I got that one right. Okay. Counterexamples are special kinds that disprove a statement or proposition. So I would put counter EX for counterexample, often used in math to prove boundaries of possible theorems. So you can test a conjecture, a hypothesis, a theory, a guess, simply by finding one wrong statement, one thing that disproves it. That counterexample disproves your conjecture. It only takes one counterexample to show that your statement is false. So a conditional statement is false only when the hypothesis is true. So you can't make up something ridiculous about unicorns. You can certainly try, but you need to start with a statement and then find that counterexample. It's used to show that a statement is not always true and therefore false. Here's a great one. If you live in Texas, then you live in Corpus Christi. Is there a counterexample? I know it says yes, but think about one, please. I live in Texas, but I live in Houston or Austin or wherever you happen to live, Round Rock. Therefore, and that 3 dots stacked up is a therefore. It's a lot faster to write those. Therefore, the statement is false. There's no counterexample to a valid argument. If a number is a multiple of 10, then it is divisible by 5, always, always. So if an argument is not valid, then there's at least one counterexample to it. Here's a great one. The sum of 2 acute angles is a right angle. Well, what about 33 and 33 or 33 and 45? To show that an argument is not logically valid, we specify a counterexample to it. I can find a counterexample to prove a conditional statement false. So here are a couple. If a number is prime, then it is odd. Write down in your notes, probably the back of your page now, it's still either 1016 or 1019, one counterexample. I came up with only one so far, and that is the number 2, which is even, but also prime. If a shape has 4 right angles, then it is a square. Write down a counterexample in your notes. I'm thinking rectangle. If an animal lives in water, then it is a fish. Write down one example. I've got probably 100 in my head right now. Whales, dolphins, turtles, frogs. I can keep going. So conditional statement examples that are true. Maybe hard to prove, but if you get straight A's, then your parents will be happy. Let me skip down to number 6. This is a math example. If I plug -6 in for G, then -6 plus 25 is 19. I'll have this deck available for you to copy or make a copy for yourself. So if you want to review the others, please do. It's just kind of fun. I always like conditional statements and counterexamples. Sort of a logic game. Doesn't feel very mathematical, but sure feels lawyerly. It feels legal to me. And also, if you're a computer programmer, this is what you'll be working with much more than math. Conditional statement examples, false. Let's come up with some examples of false conditional statements. If a number is divisible by 2, then it is a multiple of 4. Write down one in your notes that comes to mind. I have 6, 10, 14, 18, etc. Can even go in the negative direction if you'd like, -6 and all the other negatives of what I just stated. If x is any number, then x squared is greater than 2. What about 1? 1 squared is just 1. If you're an NBA player, then you are at least 6 feet tall. At least when I was watching the NBA, I remember Spuds McKenzie being 5'6". Here's some vocabulary. It's really important to at least get some of these down or recognize that a conjecture is a guess. A condit statement or a conditional statement is that if then, counterexample proves false. A theorem is something without a doubt, and a proof is a logical argument. Again, I invite you to download your own copy of this deck. Make sure you watch the video for the next class. I'll try to get posted on the Friday, or I should just say October 16, 19 folder in Schoology. Contact me by comment in Schoology or by email. Here's a great way to end. This is a conditional statement. If you study your lessons, then you get good grades.